Hey, what's up, guys? Chung here. And so this time, let's take a look at another LeetCode problem, uh, number 406, queue reconstruction by height. Okay, you are given a random list of people standing in a queue, and each person is described by a pair of integers h and k, where h is the height of the person and the k is the number of people in front of this person who have a height greater than or equal to h, right? Write an algorithm to reconstruct the queue. So what does this problem mean, right? Okay, let's take a look, right? So what is the front, right? So for example, you're given like this array here, right? Each element of the array represents a person, a people, and the first one is the height, and the second one is the number of people in front of him, right? Which is like greater or which is higher, right? Which is like higher than him, right? What does it mean? Okay, what does front means, right? Front, this is front, this is end, so it means on the basically on the left side, not on the right side. For example, here 7 means what? 7 0 means on the left side there is no other people which is taller than him, right? And 5 0 also means that there's no on the left side, left to this 5 0, there's no more people which is taller than him, right? How about the 4? As you can see, 4 here, right? Let's see, take an example 4 here. I mean, after the reconstruction here, right? So 4 means on the left of 4, there are like 4 people which is taller than him, right? Which is true because 4 and 4, the height is 4, but on the left side, see there are like 1, 2, 3, 4. There are 4 people which is taller than him, right? How about 7? 7 same here, right? 7. Let's see 7 here. There is only one element, right? Which is on the left, which is equal or taller than him, which is 7 0 itself, right? So yeah, I mean, the implementation for this code is fairly easy, but the idea is not that easy. Uh, I'll try to explain. I will try to go through the problem one by one. Uh, let's take one example, the very simple example. Let's say there are only two elements in this array. Let's say there's only 7 0 and 7 1, right? Let's break the problem into the very small problem first, right? Let's say there's only one height. There's only one height in this input array. So how can we rearrange this array, right? If there's only one height, what do? We just simply sort by the second element, right? Let's say there's a 7 2 here, right? And then we just simply sort by the second element, right? And then because that in this case the 7 0 will be our first uh, output, and then the 7 1, and then the 7 2, right? Because they are in the same height, and we just simply sort by the second element of this people, right? Okay, so that's that. How about now? Let's try to add another person with a different height. Let's say we have a height 6, right? 6 1, right? 6 1, yeah. let's say there's a 6-1 here. So then what does this 6-1 means, right? 6-1 means there is one person which is taller than him on the left side, right? I think here the key observation here is that, when we process this 6 here, the second element here will be the index. Basically, if you watch this closely, this one will be the index that will be inserting into the current answer here, right? Right, because it tells us, okay, we need two more people. We need one people in this array which is taller than I am, and that's why then it brought us to a second concept here. How can we make sure all the elements in the array will be taller than my current height, right? Then when we do the sortings, we said we sort by the second element, but then we have to sort by the first element first. Basically, we need to sort, we need to put the highest, right? The highest persons at the beginning, and then we just loop through from the highest person to the lowest person, right? If we sort the people in this sequence, then when we process a lower height, right, we can sure we can be sure all the elements we already put in the answer array, they must be higher than the current height, right? Then we can make sure our this index will be the position our current height needs to be in, because everything is greater than I am. So this is satisfy the definition of this k here, right? Because which means we need case number on my left, we basically, right? Because all of them are greater than I am, taller than I am. So I just need to insert the current, right? The current uh, element into this array at this position, which is here, right? Okay, let's say if those are the informations, let's say there's another one, right? Let's say on the height of 6, we have two elements, right? Let's say we have another 6, it has to be 6, 3, right? Think about this, right? Is it possible we have a 6, 1 and then we have a 6, 6, 2 here? No, right? Why? Because the since we have 7, 1, right? And then when we have the 6, after we inserting 6, 1, there will be like 3 elements in this array, right? So the next one has to be 6, 3. So basically, I'm just explaining, right? So basically, we're assuming, right, since the input they gave us is a correct, is the permutation of the output. So the next available one of the 6 has to be 6, 3, right? So let's assume we have two elements of the height 6 here, right? Height equals 6. And then, like I said, once we insert this one to the array, and then the second one, right? When we process the second one, we know this index will also be the index that we will be inserting to, because there are like 3 elements in this array, right? And then we just need to insert this element at the position 3 of this element. We do it one by one, since we keep inserting the element into our answer, right? Into our output. And then once we process all the heights here, then we know we have reconstruct the array here. So when if we really see this, or if we're really asked this question during an interview um, it's uh, it's not that obvious. I don't think everyone can come up with this kind of observation really quickly and easily. Especially if it's especially we need to first start from the highest height to a lowest height. And then second one will be, oh, the second element will be our index to insert, right? So I think if you were really asked this question during interview, try to communicate with your interviewer, and yeah, don't just spend like half an hour st uh, s standing there and trying to solve this problem by yourself. Just try to talk to your interviewer, ask them what you have thought, and most likely, if the interviewer, the most interviewers, they're kind of, they will give you some hint one way or the other, right? And then you can just use that hint to help you further uh, uh, get further, I mean, further down to help you to get close to the real solution here, right? Which is this kind of thing. Um, all right, sorry about all those kind of nonsense talk. Let's get down to the coding here, right? All right. Uh, okay, so like I said, we first need to sort all this element here, right? Like we said, we need to first sort by the the height and then the index, right? Let's do a sort, right? The key. Let's use a lambda function here. So what do we sort, right? So first we said we need to sort the element from top down, right? But then the second one we want to sort the second one from smallest to the biggest, right? But on the first one it has to be highest to lowest. So what do? We just use a small trick here, right? We first sort the negative number of the first one, right? And then the second one will be sorting on the positive one, right? So after this one, we're sure we're sorting the highest one on the beginning, and then uh, also for the same height, we from the index sort the index from the smallest to the biggest, ascending order, right? And then we just do a loop here, right? Do a loop here. First, let's define an answer output here, right? So uh, we do what? We do the height. Yeah, we just simply do a insert, right? Since we already sorted everything, we just need to insert the position. So what's the position, right? The position will be P1, right? The P1, and the value will be P, right? I think that's that's the definition of the insert here. Basically, we specified the position we want to insert, and then what's the value of the what value we want to insert. So the position will always be basically the index here, right, on the second one. And then in the end, we simply return the answer. See, only a few lines of code, but the thought behind those code are kind of not easy to get at the beginning. Yeah. So uh, sorry. Yeah, for P in people. Yeah, some typos here. Yeah. Yeah. See, so cool. So again, two thoughts here, two hints here, right? Yeah, let's take a look what this hint says. Yeah, anyway, so first one, yeah, I don't know, maybe I should stop here. Basically, we need to sort from the highest to lowest so that when we do the insert, we know that all the elements in the answer will be either taller or the same height as I am as the current one, right? So that we can safely use this index, right, to do the insert. And in the end, we just return the answer here. Cool. I think that's it for this problem. Thank you so much for watching the video, guys, and I hope you enjoyed. And okay, see you guys soon. Bye.